Hello everyone, welcome back to my channel. Today let's go over another medium premium question that I just solved on my own. So I'm really glad about this and I'm happy that I was able to come up with my own solution to this question without any assistance. So let me show you how I did it. This one's called longest semi-repeating subarray. It is the latest question I think on the website. So yeah, let me show you what I did. So this one, you're basically given an integer array and this integer called k and a semi-repeating subarray. You just want to find the longest length of this possible subarray. So let's go ahead and declare an integer, and it's just going to be a subarray which at most k elements repeat. So for example here, right, the biggest frequency is 2, or 3 has a frequency of 2. Nothing has a frequency that's bigger than 2, which is k. That's at most allowed. So then you can take the length of that subarray and factor it into the final answer. Okay, so let's go ahead and do the naive solution, which is just to get every single subarray. And let's create a dictionary. And let's go ahead and just tally up every single element. So now if the current element appears more than once, then we can just add it to a hash set called scene. Let's say scene.add nums of j, because the set obviously doesn't have duplicates. So then we can just ask if the scene has at most k characters, then we can still take the length of the current subarray because that's still valid. So we can just say we can update answer to the length of the subarray, and then at the end we can just return answer. So this is an n squared solution. Obviously it's not going to pass, so let me show you how I optimized it. So just let it time out. Okay, so 603 out of 639. So the idea I came up with was to use a sliding window approach. So let's go ahead and just loop through nums once in one pass. So let's we still have the same dictionary, and we're just going to say c of nums of right plus equal to 1. Okay, so we're just going from left to right, and we're tallying up every single number, and obviously we still want a set, and the idea is to say, so let's say we reach this point and we have over k elements in the window that have a frequency of, there's some element in the window that has a frequency bigger than k. Okay, so at that point we just want to keep shrinking from the left until that satisfies k, and then we can take the length, and then we can keep going to the right, keep expanding the window. So we're going to keep shrinking to satisfy k, and then once we do, then we can take that length, because once you shrink up to a certain point and you're satisfying k, that's going to be the longest result you get, and then you can keep going forward with the window. So now we can just say while the length of scene is bigger than k, because obviously this hash set is going to hold all the elements that are unique, and then we can say if left is less than right, because the window can't cross itself. In that case, we can say c of nums of left minus equal to 1, and then obviously if c of nums of left is equal to 0, then we can just delete it from the hash map, and this is just the way of shrinking the window. So now what we can do is basically we only care about if c of nums of left has a frequency that is basically less than or equal to 1. If that's the case, then we can remove it from the set, because that's now valid, that now satisfies the condition of k. So it can say scene.discard, because we don't want to remove if it's not in the hash set already, because we're just going to say if c of nums of right is bigger than 1, then we can just add it to the hash set, because then it's starting to be tracked, because that's an element that has a frequency of bigger than 1. And yeah, so we can discard it if it reaches k, so not 1 but k, and then obviously this is just standard stuff right here. And then after that we can just say, because at this point it is equal to k, right, or less than k, but it's going to be equal to, because we're only caring about when it's violating k. So after that we can just take the size of the window, and this is going to be O of n instead of n squared, because this is not, it doesn't have to go towards the end of the array, and then after at the end, then we can just return the answer. Okay, let's run this. Okay, submit it. Okay, so looks like we failed some edge cases here. So the window can have one element. Okay, submit it. Okay, so looks like we still have some issues here. So we're going to discard nums of left if it's satisfying k. And if it's equal to 0, then we're going to let's see. So if it's bigger than k, then we have a problem, right? Otherwise, we're going to keep adding it because it only has k elements inside. And we're going to keep shrinking the window. And then if it's less than or equal to k, then we're going to discard that left element. But I guess we still have to see if nums of left is equal to 0. We delete it. So obviously, if it's equal to 0, then we also have to discard it from scene, right? I assume that's what's going on. So let's go ahead and use this test case. Okay, so still wrong. Okay. So at most k elements. Oh, if it's bigger than k, sorry, if it's not bigger than 1. Well, no, this is just how many elements are repeating, so it is bigger than 1. And then so if it's less than or equal to 1, perhaps we can discard it because that is meaning it's not a duplicate anymore. So that's different from k. K is just a constraint for at most k elements. This is just duplicates, okay? So let's submit it. And there you go, passes all test cases. So again, I'm really glad that I was able to solve this question on my own and come up with my own solution to this problem without any help. So also achieving a 100% runtime in memory, which is pretty rare for my own solutions. So yep, that's it for this video. Thank you for watching and stay tuned for more.